Okay, so today we're going to talk about polygons. Just to refresh our memory, poly means many. Okay, so when we talk about polygons, we are talking about a shape that has 3 or more sides. Okay, so poly means many. Anything from a triangle all the way up to a dodecagon would be a polygon. Anything with 3 or more sides. One of the things that we need to talk about is we need to name some of the parts of a polygon. So any corner, like C or D or B, those would be, each of those is a vertex. And when we have plural, we would have vertices. The next thing we would talk about is the side. Okay, so the side would be anything like this. Okay, so those would be the sides. Go ahead and do all the vertices since I did all those. Okay, so we have vertices and we have sides, something that we've been talking about this entire time. The next thing that we have that would be new is we would talk about diagonals. So a diagonal goes from one vertice across the polygon. It's going to skip one. From B to C would just create a side, but if I skip a side and go to the next vertice, it creates a diagonal. So this would be a diagonal. Okay. I can also go from B to E. That would be another diagonal. I can go from A to D. I can skip B and go from A to C. And I can go from C to E, skipping D as in dog. Makes a star. All of those are diagonals. Okay, so let's go to this next one. Let's go over some of the properties. Okay, so some of the properties of a polygon is, 1, it must be closed. Okay, that's one of the properties. It has to be closed. The next thing is it cannot have any curved sides. Okay. All right, so let's go look at this first one. Let's look at A. Yes or no, is this one a polygon? Yes. It is closed, doesn't have any curved sides. The next thing they want me to do is name it. If you look down a little bit further on your notes, you can see the names. All right, so we have 1, 2, 3, 4, 5. Those are not tick marks. I'm just counting the number of sides. So I have 5 sides. So when I look down here and I see, we would call that a pentagon. Okay. What about this next shape, B? Would this one be a polygon? No. Okay, so if I had the top shape or just the bottom shape, I would have triangles. But because this shape as a whole crisscrosses and it closes off and it's not an open in the middle, it is not a polygon. Okay, let's look at this next one. Looks like a bow tie. Closed, all the sides are straight, yes. Let's see, there's 1, 2, 3, 4, 5, 6, 7, there's 8 of those, so octagon. Okay. Let's do a couple more. Let's look at the next one. Let's do 1A. Is this one a polygon? No, it has to be closed. That's missing. Yes. Okay, we would count the number of sides so that we can name it. This one would be no, has a curve, okay? The next thing we're going to talk about is if something is concave or convex, okay? So just like concave sounds like, if you was to shove in the side of the box and cave in the side of the box, we would say it was concave. So if you look at this one, it looks like somebody just pushed in the side of that triangle. So we would consider that one concave. Convex is, think of like a balloon if you would blow it up and there's no pushed in sides, okay? So like our perfect box that we packed something in. So concave is pushed in side. The other way to think about that is this is my diagonal, and if my diagonal is on the outside of the shape, then it becomes concave. But here, all of my diagonals are on the inside. So diagonals will be on the outside of a concave. All of my diagonals will be on the inside. All right, so here we go. This little part right here is going to go with what's on the back. We'll talk about that in just a minute. It's kind of out of order. So let's go down here and decide whether or not these are convex, concave. Something we didn't talk about right off the bat was regular and irregular. So regular means, just to refresh our memory, all sides, all angles are congruent, okay? All right, so let's look at this one. This one would be convex, okay? Nothing's pushed in. It is not going to be regular, even though all of my angles are the same. We have 1 tick mark, 2 tick marks, so this one's irregular. Okay, let's look at this one. This one would be convex. Nothing is pushed in. Every vertice is got congruent angles, and all sides have the same tick marks, so this one would be regular. All right, let's look at our star. This one's a little tricky. A lot of us are going to want to say that this one is regular, but it's not. Let's think about this angle right here, this angle right here, and this one right here. None of those are going to be congruent to these. So this one has got pushed in sides, so it would be concave, irregular. Right, let's look at the next one. This one, all the same, all the sides, all the angles, so this one would be regular, convex, nothing's pushed in. All right, let's look at this last one. This side here is pushed in. Our sides are not the same, so this one will be concave, irregular. Okay, let's move on to the back. Before we do that, this here is going to be very important. N minus 2 times 180. This will tell us the measure of the interior angles of any polygon. Okay, so put a star by this. You will see this from here on out. You will use this on the test. We're going to talk about how they came up with that. Let's see if it shows that shape. All right, so they don't show me anything on the back. So let's go over here to the side and let's make some notes about how we get this. Let me just make any shape here. Well, let's start with a triangle. A triangle adds up to 180 degrees. And anytime I have a triangle, I have 180 degrees. So what if I just draw this random shape? Okay. And I do my diagonals. There's a triangle, 180 degrees. Here's another triangle, 180 degrees. Here's another triangle, 180 degrees. So I have 3 180 degrees. I'm running out of camera space here. All right, so let's look at this. So 3 times 180. If you don't have a calculator out by now, get one. 540 degrees, okay? Now, there was 1, 2, 3, 4, 5 sides. So there's 5 sides. And according to that formula, n minus 2 times 180 should get the same thing if we decided how many triangles there were. So the number n is the number of sides. So 5 minus 2 times 180 gives me 3 times 180, which is exactly what we just came up with. So you're probably thinking, why not do the triangles the whole time? Well, they're going to give you a shape that says you have 120 sides. Tell me the total degrees, the total angle measures of the interior. Well, you're not going to want to draw out a 120-sided figure. You're going to want to use the 120 minus 2 times the 180. Okay, so let's do some of these examples on the back. Okay, so it says we have a convex. It wants to know the sum of the interior angles, okay? So sum of the interior, that's the n minus 2 times 180 of a convex octagon. Okay, what's an octagon? It's 8 sides. So 8 minus 2 times 180. Okay, so 8 minus 2 is 6 times 180. Equals 1,080 degrees. Okay, whether or not it's convex or concave does not matter. Okay, let's look at B. It wants us to find the interior angles of a regular nonagon. Okay, so if it's regular, that means they're all equal, but they're not asking us to find each individual one. They're just asking me to find the total. A nonagon. So if you go back to your chart and look, a nonagon is, it's not on your chart, so I need to get you guys a chart. So I will make a copy of a chart for the teacher to hand out to you. You can always Google this as well on your Chromebooks. A nonagon is a 9-sided. Okay, so we have n minus 2 times 180, 9 minus 2 times 180, so 7 times 180 degrees, which would be 1,260 degrees. Okay, so let's look at the next one. Using what we've just learned, now we're going to decide what each one of these angles is going to be. So they've just given them a variable and they have a ratio. This would be like a 3-to-1 ratio with these, but we need to find out what the total is. And since it's 4 sides, we would do n minus 2 times 180. Okay, so 4 minus 2 times 180 gives me 2 times 180, which is going to give me 360 degrees. But they want to know each one of these individual angles. Okay, so here's what we would do. We would add all the angles and they have to equal 360. So C plus 3C plus 3C plus C has to equal 360 degrees. So this would make 4, and 4 would be 8, so 8C equals 360. Divide both sides by 8, and C would equal 45. Now, this only answers part of that question, okay? It only answers the ones that are just C. The ones that are 3C, we would have to take 3 times 45. Okay, so each of these would be 135 degrees. Okay. All right, on 3A, it asks us to find the sum of the interior angles of a 15agon. Okay, so that means when they write it like this, this is the number of sides. Okay, so when they say that, that's the number of sides. So basically, this is just plugging into your calculator. Okay, plugging it into the formula, putting it into your calculator. So n minus 2, so 15 minus 2 times 180. So 13 times 180. So that's 2,340 degrees. Okay. That will give me the sum. That's my total. So when they ask for sum, think of total. On this next one, they only want each individual one. And what they tell me is I have a regular decagon. Okay, so deca is 10-sided. And if it's regular, that means every single angle is exactly the same. So the first thing I'm going to do is I'm going to find my total. So deca is 10. So 10 minus 2 times 180. So 8 times 180. Equals. Okay, so think about if I have a decagon. If I have 8 sides, I'm going to have 8 angles. And every one of those angles is exactly the same. So if that's my total and I have 8 that are exactly the same, I would just divide this by 8. That would give me each individual one. Okay, so each one of those angles is 180 degrees. That's not right. Decagon, I'm sorry, a decagon has 10. 10 angles, 10 sides, so we would divide it by 10. Okay, which would be 144 degrees for each one of those. Sorry about that. This would be the total number of angles. Okay, each one of them is exactly the same. All right, so the very last part of this is the exterior. Okay, so on the exterior, it is the same in every single shape. It doesn't matter what the shape is. It could be 100-sided. It could be 5 million sided. It's always going to add up to 360. Okay, these are the exteriors. All right, so A is right here. Let's do A. It says find the measure of each exterior angle of a regular hexagon. Okay, so a regular hexagon. If something is regular, all angles, all sides are all equal. All right, so a regular hexagon. So the first thing I need to know is the total. Well, the total's 360, no matter what. Doesn't matter the shape. If all of my interior angles are exactly the same, then all of my exteriors have to be the same. So I just need to divide it by the number of sides. When I talk about a hexagon, let's see if that's on your chart. It is. A hexagon is 6 sides. So 360 divided by 6, 6 goes into 36 6 times, and the 0. So each one of those is 60 degrees. You have to remember this word. Regular means all angles equal. Okay, let's do this last one, and then we're done. You guys can go to the homework. All right, so they want to know what the value of A is. So this is kind of like the one that we did with all the interiors. Everything on the outside has to add up to 360. That is according to the rule. Okay, so what we're going to do is we're going to add all those up. So we have 7A plus 2A plus 3A plus 6A. I'm running out of room, plus 2A. All right. So 7 plus 2 is 9, plus 3 is 12, plus 6 is 18, plus 2 is 20. So 20A has to equal 360 degrees. Remember, it's exteriors, always 360. Divide by 20. 2 goes into 36 18 times. Okay? So A is 18. Now, they only ask us to find the value of A, so we're done. If they wanted to know what each angle was, we would have to take that and substitute it back in. But since they only asked the value of A, we're done. All right, so you are going to do page 398, and that is all due tomorrow.